Autonomous Vehicle Science Lecture Series, number 6. Safest Vehicle, from MotionLab. The fastest response means the safest vehicle. A vehicle's response time is the time between an instant sensors detect changes in the surroundings and another instance the vehicle's motion changes accordingly. If the response time is minimal, the possibility the vehicle handles an emergency situation appropriately increases. Thus, the possibility of causing accidents becomes also minimal. The vehicle control architecture shown in the next slide embodies theoretically the shortest response time. This architecture responds to sensor input within a single motion sampling cycle. For instance, the Swan vehicle adopts a 64 Hz motion cycle, which gives the motion sampling time of 15.625 milliseconds. Vehicle control cycle runs within a single motion sampling cycle, number 1. This diagram describes the entire MM vehicle control architecture. It executes all steps in a single motion sampling cycle. A timer interrupt triggers this vehicle motion cycle, self-localization, sensor data input, execute a geometric motion, a motion command, V, kappa, or V, omega, is produced, vehicle mechanisms, embodying motion. Vehicle control cycle runs within a single motion sampling cycle, number 2. 1. Self-localization is the updating vehicle's frame, XV, YV, θV, task. This computation uses only a few equations of the 2D transformation theory. 2. We extract only a couple of numbers from sensor data for GM execution. See the next slide. Input parameters for GM. 2.1. takes the sensor data in a polling protocol. When wants a new data, if the sensors are ready, the data is handed. Otherwise, gets an old data. 2.2. never waits for the sensor task's completion. 3. A GM executes only a few equations to obtain kappa, V, or omega. 4. Transferring V, kappa, or V, omega, takes only a minimal time. 5. The embodying motion command task uses the rest of the motion sampling time. Input parameters for geometric motions. Direction tracking GM. Direction equals alpha, gain G. Line tracking GM. Line equals XL, YL, theta L, gain G. Circle tracking GM. Center equals A, B, radius equals R. If R greater than 0, counterclockwise. If R less than 0, clockwise, gain G. Park GM. Destination frame equals XD, YD, theta D, forwarding, backward. Curvature-defined GM. Kappa equals kappa, S, 0 less than equals S less than equals S. The size of each input data is small. This lightly demanding input data requirement minimizes data transfer time and influences the task of sensors. The vehicle, Swan, demonstrates the quickest response time in negotiating with this irregular object. We deliver the best motion creation capacity for self-driving cars. MotionLab possesses sensor-independent and vehicle hardware-independent motion creation technology for self-driving cars. If your company is interested in our licensing offer of the MM technology, please visit our site motionlab.info with DreamCar as the password and click the Contact button.